This is section 11.2 on permutation. A permutation is an arrangement. Order matters. That's a major thing to keep in mind for permutations. And the other is no item is used more than once. We're basically on permutation placing an object, and once it's been placed in a position, it can't be placed again. So example, based on their long-standing contribution to rock music, you decide that the Rolling Stones should be the last group to perform at the four-group Offspring, Pink Floyd, Sublime, and Rolling Stones concert. So there will be 4 groups performing. And you, as the person in charge, want the Rolling Stones to be last. So how many groups can occupy the last position? Just one. You want the Rolling Stones to go last. So now they have been placed. These 3 can go in any order you want. So how many can you put in the first position? Any of 3 could go in the first position. But once you have placed that group, and you've already placed the Rolling Stones, how many groups are left to place? So pretend you had put the Sublime in there. How many groups are left? 2. Pretend it was Pink Floyd. How many groups left? 1. So you have a possibility of 6 arrangements. 3 times 2 times 1 times 1 will give us 6 different ways for you to arrange your rock concert. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? You're arranging 7 books, so put your slots down. 3, 4, 5, 6, 7. You have 7 books. Anybody can go in the first position. Now, once you have placed that book, it can't be placed again. That number can't be used again. So how many books are left? That would be 6. Now, how many books have you already placed? You've already placed 2 because you've used up 2 slots. How many books are left? 5. Now you've used up 3 slots. How many books are left? 4. And are you seeing the pattern here? 7, 6, 5, 4, 3, 2, 1. And what we need to do with all of this is multiply all of these together, which equals 5,040. What we just did is called a factorial. Notice we went from 7 all the way down to 1 in our product. It is called factorial, and it's written with the exclamation point. So when you see this, don't say 8 little exclamation point thingy. It is called 8 factorial. That's what that symbol means, factorial. And what it means for us arithmetically is that we begin at whatever number that is, and we keep multiplying by the number that is 1 less. So we started at 7, went down to 6, went down to 5, etc., and we stop when we get to 1. So if we had just 3 factorial, we started at 3, dropped down to 2, dropped down to 1, and that's our product. So that's the factorial notation. There is a button on your calculator. Depends on what kind of calculator you have for this button. So just find out in class what kind you have. So factorial notation is this. If n is a positive integer, the notation n factorial is the product of all positive integers from n down to 1. Also, by definition, 0 factorial is 1. That's kind of weird, but 0 factorial is 1. Going back to this one, instead of writing out all my slots, as soon as I saw that I needed to arrange 7 of my favorite books, automatically it's 7 factorial. And if you know where that button is on your calculator, you can press it and automatically it will give you this. So sometimes you're going to want to use slots, and sometimes you will be able to use the formula and your calculator. Sometimes there are less slots than items that need to be placed. So how about you need to make a batting order for a baseball team with 12 players, but only 9 players play at a time. So that means I'm going to have 9 slots, but I've got 12 players to play. So of course that means some people aren't playing, but I've got my 9 slots, I've got 12 players, and it says assuming that all players could bat in any position, how many different batting orders are there? Well, the first slot could be occupied by any of 12 players. Once I've placed that player, what's left is 11, and then what's left after that is 10, and then 9, 8. It's looking like a factorial, but the difference is it stops here at 4 because I didn't have enough slots for all 12 players. So this is the product that I need to enter into the calculator, and that is 79,833,600 different batting orders. Now there is a formula for what we just did. So this is the idea of n things. This was our 12 players taken r at a time. That's referring to the fact that I had 9 slots. So the first number is your number of items, and your second number is the number of slots, or the number of positions. And this is what the formula says: n factorial, which is that first number, over the quantity n minus r factorial. So if we look at the baseball example using the formula, it is simply 12p9. And scientific calculators have that button somewhere. So if you find that button, you can enter it and not have to do the arithmetic. If you don't have a scientific calculator, you're going to have to write this out following the formula. So this is 12 factorial over quantity n, which is 12, minus r, which is 9 factorial. So what this works out to be is 12 factorial over 3 factorial. So writing this out will explain why the previous screen stopped at 4 like it did. There's my whole 12 factorial, but I'm dividing out 3 factorial. 3 times 2, those are going to cancel. Of course, 1 doesn't even need to be there, and there's my same product as before. So when you look at these kind of problems, it is your choice if you want to use the slots or if you want to use the formula. Just do whatever works for you. Now there's another permutation formula that is this. It's talking about, we want to find out the number of permutation of n items where p items are identical and q items are identical, etc. Now that sounds really strange, but it's this idea. Let's say I have this word DD, and I want to see how many ways I can arrange this name. Well, according to this formula, it is a total number of letters, factorial on the top, divided by the number of repeating letters, factorial. So I have 2 D's. That's going to give me a 2 factorial. I have 3 E's. That's going to give me a 3 factorial. So what's going on here is that the total number gets factorial on top, and all the repeats go on the bottom with a factorial. And I can enter this in the calculator now. If you're going to use this on the calculator, you will need to put parentheses around the bottom part. If you want to write it out step by step, we're looking at 5, 4, 3, 2, 1. 2 factorial is 2 times 1, but I'm just going to write 2. 3 factorial is 3 times 2 times 1. And we got lots of stuff that cancels. The 3's, the 2's, of course the 1's. Then I could do 2 into 4 twice, and I end up with 10 different ways to arrange the letters in the word DD. And the reason we have to divide these things out is that we cannot distinguish between this E, let's say, and that E. So that's why we have to divide out the repeating letters. So this is used anytime you have repeating letters. I've seen problems with repeating colors, like on a flag. I've seen repeating numbers. So let's see another example. Let's see about arranging the letters in the word Mississippi. So the first thing you need to do is count up the total number of letters. There are 11 letters. Then we want to go through here and look for repeats. There's 1, 2, 3, 4 I's, factorial. You have 1, 2, 3, 4 S's, factorial. And you also have 2 P's, factorial. If you're going to enter this directly in the calculator using the factorial button, you've got to be sure you put the bottom in parentheses. Now let's write this out the long way. 11 factorial, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I don't need to write the 1. Then 4 factorial, 4 times 3 times 2 times 1. The next 4 factorial, 4 times 3 times 2 times 1. And the 2 factorial is 2 times 1. And then we can do some canceling. 4, 3, 2, 1 can wipe out with 4, 3, 2, 1. Then what I do is I go through here and just kind of pick and choose stuff. Like I see 4 times 2 on the bottom. 4 times 2 gives me 8. I can wipe that out. I have a 3 times a 2 over here, gives me 6. And what's left to multiply is 11 times 10 times 9 times 7 times 5. Everything else has been wiped out, and I get 34,650. Now, once you do enough of these, you're really not going to write all this out. What I do when I start to write this out is I write the 11 factorial. So 11, 10, 9, 8, 7, 6, 5. And as soon as I get ready to start writing the 4, I go, oh yeah, there's a 4 factorial down there. I can just wipe out that 4 factorial and quit writing in the top. And then I have the 4 factorial, 4, 3, 2. And no, you don't need to write the 1 times 2. Now, if you don't like the canceling idea, then you can use your calculator and multiply all this top stuff up, whatever that is on the top, multiply all this bottom stuff up, put that on the bottom, and then use your calculator to divide it out. Or put all this in parentheses, divided by all of this in parentheses, and the calculator will do it for you. So far with the permutation formulas, we have this idea. You're going to arrange n items. It is just n factorial. There's no special stipulations. You would like to arrange 10 cars in a row. You would like to line 7 people up in a row. You would like to take 8 books and put them on a bookshelf. All of that is arranging n items is n factorial. Now you might have to arrange n items in r places. This is the idea of you got less slots and items. Things like I want to arrange 10 books, but my bookshelf only holds 7. N items where there are some duplicated items. This way I'm putting capital N to be my total number of letters or numbers, and the bottom is all of the repeating letters or colors or numbers. Of course, everything's factorialized. So let's do some problems and see which of these formulas you would use, if at all. You can always go back to slots if that's what you'd rather. All right, there are 7 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances? This is just arranging 7 comedy acts. It is 7 factorial, which is 5,040. This one says there's 8 performers who will present their comedy acts this weekend. One of the performers insists on being last. As soon as I read this special stipulation, that says to me I need slots. 3, 4, 5, 6, 7, 8. There's one person who insists on going last. Now, once you have placed that one person, you don't have 8 performers anymore to place. You only have 7. And once you've placed that one, then it goes down to 6. Now it's looking more like a factorial. And of course, we're going to multiply all those together. And you could just type that in the calculator as is, or you could recognize that that part right there is 7 factorial and use that button on your calculator if you want, and that equals 5,040. A club with 7 members is to choose 3 officers, president, vice president, and secretary-treasurer. Does order matter? And the answer is yes, it does. Choose 3 officers, president, vice president, secretary. We have any of 7 people that could go in the first slot, and then whoever we've chosen there can't go in this slot, down to 6, down to 5, which gives me 210. Or it is this idea. We are 7 members. We are going to arrange 3 of them. It'll give us this 210. In a race in which 10 automobiles are entered and there are no ties, how many ways can the first 3 finishers come in? Well, that is definitely an order thing. If 10 cars could win, and once that car has won, there's 9 other cars. And once those guys have come in, we're down to 8 cars available. Multiply that together is 720. Or, using the formula, it is 10 automobiles to be arranged in 3 positions. And how many distinct ways can the letters of the word bell be arranged? Distinct is a good tip-off that we're going to be using that formula about the repeat letters. So we've got 5 letters total on the top. And on the bottom, we have 2 E's, so 2 factorial. We have 2 L's, 2 factorial. So to write this out, 5, 4, 3, 2, 1. 2 factorial is just 2, and this one is just 2. So cross out those 2's. I could reduce 2 into 4 and get 2. Then I'm looking at 5 times 2 times 3, which is 30. How many ways can the digits in the number 8,440,000 be arranged? Because I can't tell between any of the 4's or any of the 0's, I have to use the same formula. So what I have is 7 total digits, and I have 3 repeating 4's, so put a 3 factorial, and I have 3 repeating 0's, put another 3 factorial. So 7, 6, 5, 4, and right now I know I should write out a 3, 2, 1, but I really don't have to because I can cross it off with one of those 3 factorials. And now what's left on the bottom is a 3 times 2.